Hi there, and welcome to another college math video. In this video, we're going to continue looking at statistics. Previously, we looked at measures of central tendency, and now we're going to look at measures of dispersion. So in this video, we have only one objective: determine the range and standard deviation of a set of data. This is one of those sections where it's quite a bit of number crunching, to be honest, but let me just talk a little bit more about measure of dispersion. So measure of central tendency takes the data and summarizes it down into one specific, maybe centralized kind of number, and we saw a few different ways to do that. Measure of dispersion tells you, okay, based on this kind of central data, sometimes based on that central data, how much variation, how much variability is there in the data? We'd get a larger number if there's a lot of variation in the data, and we'll get a smaller number if there's not as much variation. So we'll look at that in two ways: range and standard deviation. So let's get the notes on how exactly to do both of these things. The range is a quick one, and that's why we're going to talk about it first. This simply is the highest value minus the lowest value. This very easily tells us how much of a span there is amongst the data. If your highest is 10 and your lowest is 2, 10 minus 2 gives you 8. You know that there's a variation of 8 numbers along the scale of data pieces that you're seeing. And it's always dependent upon the data to know if that number, the range is a high one or a low one. If 8 was the number and we're talking about dollars someone makes every year, obviously that's a small number. If 8 is the number and we're talking about the variation in number of children a family has, 8 is a pretty large number. So you have to, on the backside, take that information and understand, does it mean something big or is it not too significant, and kind of what you can do with that information. So range, a very simple computation: highest minus lowest. What's the range of the data? Standard deviation, definitely a more complicated computation. So I'm going to first give you what it does. This measures how much the data differs from the mean. From the mean. Remember, with measures of central tendency, mean is just one of the many that you can use. When it comes to standard deviation, this is specifically using the mean to find out how much variation there is amongst the data. So standard deviation, let's get the formula for it. S is the variable that we see. And I'm going to write down the formula first. It looks like a very complicated mathy formula, and it kind of is. But I promise each piece is really easy to be broken down. So underneath the radical, we have a fraction. On the top of that fraction, we have the summation, this kind of hard-lined looking E, means summation of, or the sum of, x minus x bar, so x representing data points minus x bar, remember in the previous video, is the mean, quantity squared. So it's the sum of each data piece minus the mean squared, all over under the radical, n minus 1. And we're going to write down exactly what each of these means. So let's go red. Here's the verbiage, the word translation of what this numerator means and how we can do it. So it's each piece of data minus the mean and then squared and then added together. So that's exactly kind of what it translates to that we're going to do. We're going to take each piece of data, subtract the mean from it, then square that number, and then we'll do that for each data piece, so we'll have a whole bunch of numbers and we'll add them all together. That's the numerator. The numerator is the most complicated piece to get in our standard deviation. The denominator, simply n minus 1. This is the number of data pieces minus 1. That's it. So you'll know how many data points you have. Subtract 1 from it, you have your denominator. Those two numbers are under the radical, so you'll do the division, take the square root. You can do that at the same time in the calculator. Not a problem. Again, as with some of the things in the previous video, standard deviation is something that can be found on a higher powered calculator. There are too many variations and types of calculators, and we really don't touch on this for that long. So I'm not going to introduce that part of it. What I'm going to show you is how to do it by hand. But you're more than welcome to find another video that shows you how to do it in your calculator and then use that to get standard deviation. Alrighty. So let's go ahead and see an example of this then. Okay, so we have some data pieces that we're going to find the range and standard deviation for. And instead of making us find the mean this time, because we need the mean in order to do standard deviation, I'm going to tell you the mean is 12. Sometimes you'll be told that, sometimes you will also have to find the mean. So let's start with range, because in my opinion, range is the much easier thing to find. I'm leaving myself some space at the bottom because I'm going to use a chart to do this. The range is simply the highest piece of data minus the lowest piece of data. So our highest piece of data is 18 minus our lowest piece of data is 7, so our range is 11. The data spans amongst 11 different numbers. Again, this data we're not told what this data represents, which is fine. That part of the analysis could come later. What I'm concerned with right now is you being able to actually do these computations. Okay, so then let's go to standard deviation. So remember, let's list the formula again. So it's top of mind, the sum of x minus the mean over n minus 1. If you've looked at any statistics classes before, or maybe taken a class that used it, you may have seen a slightly different version of this. There are different versions of standard deviation that are used. This is kind of the basic, most common one, and this is the one I want you to use for this class. This is what the calculator would do if you're using the calculator. But there are reasons that the other one would get used, the other versions could get used. Don't worry about those. For our purposes, just use this one. Okay, so what we're going to do in the chart is just the numerator. This is simply to get the numerator. And remember, in words it says we're going to take each piece of data, make a column, then we're going to subtract the mean from it. We'll have a number there. Then we're going to square it, whatever that number is, the data minus mean number that we already got, square it, and then we add them all together. It's the sum of each piece of data with the mean subtracted and squared. So our pieces of data are 7, 9, 11, 15, 18, and 12. All right, there are our data pieces. Next part to get that numerator is subtract the mean from them. The mean we have already established is 12. So 7 minus 12 gives us negative 5. 9 minus 12, negative 3. 11 minus 12, negative 1. 15 minus 12, 3. 18 minus 12, 6. 12 minus 12, 0. Next, we have each piece of data minus the mean, then we take that value and square it. Negative 5 squared. If you're going to use the calculator for that computation, be careful. When you type it in, the negative 5 has to be in parentheses. If you just type minus 5 squared, the calculator is only going to read that the 5 is squared and not the negative. Basically, every time you're squaring a number, the negative disappears here. So you can do it by hand, you can do it in the calculator, whatever you want. Negative 5 squared is 25. Negative 3 squared, 9. Negative 1 squared, 1. 3 squared, 9. 6 squared, 36. And 0 squared, 0. So you can start to get a feel for at least that some of these data points are causing a bigger pull than others. And that's kind of what the squaring does here. It serves two purposes. Gets rid of the negative that's involved, and then also really shows you where the variation is. So this isn't the final answer yet. I just want to point out 7 is one of the numbers that's a bit farther from the mean than some of the others. And so when we come to a piece where we're under the radical, 25 is one of those numbers. There's a bigger pull there. Same with 36. And then 12 actually is the mean, so there's no variation from the data there. Okay, so remember from the numerator, data minus mean, quantity squared, the sum of all of those things. So add them all together. 25 plus 9 plus 1 plus 9 plus 36 plus 0 gives us 80. This chart came up with the numerator of our standard deviation under the radical. Okay, then the denominator is simply the number of data pieces minus 1. So we have 6 data points in this case, so it'll be 6 minus 1. And then all we're doing is plugging this in the calculator. You could do it all at once, you could do a little bit more simplifying. 80 over 5, and then 80 over 5 gives us 16. And the square root of 16 is 4. Certainly, plus or minus 4 whenever you're taking a radical, but for our purposes, just the positive version is good enough. So we get 4. This number is a number you can use to compare to other data sets. So if the standard deviation for this data set was 4 and the standard deviation for another data set was 3, we would know our current data set has more variation. That single number tells you how much variation there is, and it's helpful to compare to other data sets. So I have a mean of 12, standard deviation of 4. All right, so this is the nuts and bolts of how exactly you find range, hopefully pretty easy, and standard deviation. Okay, so the next 2 slides are both problems I want you to do as practice problems. For the first one, you are not given the mean, so you have to find that. Trust me, it works out to be a nice number. Use that, use the chart, go through the whole process, find both things, range and standard deviation. And then the second problem is going to use some data from the previous video. All the data is represented here again, so you don't have to look back. Again, find range and standard deviation. And again, you don't have the mean, so you're going to have to find it. But please take heed. Round your mean for this question to the nearest whole number. Nearest whole number. If you use a decimal, your computations, while more accurate, are very complicated to deal with. So round mean to the whole nearest whole number. All right, so go ahead and pause the video, go through both of these problems on your own, come back and let's see if we're on the same page. All right, so after much calculator computation, you're ready to see if you have the right answers. So let's go ahead and go through these. This data is on waterfalls that are in Venezuela: Salto Angel, Salto Utaje, Salto Roraima, and Salto Cucanan, and their respective heights in meters. All right, so let's start with range. Range is going to be the highest minus the lowest. Our tallest here will be Salto Angel. As we see, it's the tallest waterfall in the world. And we'll subtract the lowest of these 4 waterfalls, which looks to be 610. So subtract, and we get 391 meters, or just 391 is fine. So there's our range. There's a 391 meter span amongst those 4 data points. All right, then standard deviation. So let's get a chart going for data. Data minus mean, and then data minus mean squared. First, we need the mean. The mean, remember, is the sum of all the data points divided by the number of data points. If we add up all 4 of those, we get a nice number of 3,000 divided by the 4 data points gives us 750 as the mean. All right, so our 4 data points, if you put them in order, that's fine. It doesn't really matter when you're doing this computation because you're going to do all of them separately. And 674. So we have data point minus the mean, which is 750. 1001 minus 750 is 251. 715 minus 250 is negative 35. 610 minus 750, negative 140. 674 minus 750, negative 76. Okay, then we take that number and square it. And yes, these are some large numbers: 63,001, 1,225, 19,600, and 5,776. So now we've taken each data point, subtracted the mean, squared it, and the last thing, add them up. The sum of those 4, 89,602. So now we have our numerator. So underneath standard deviation, the radical, we have 89,602 over number of data points, which is 4 minus 1. 89,602 over 3. If you divide, let's see, you won't get a clean number, so this is what I would type into the calculator. And when we type this into the calculator, we get 172.82, a bunch more decimals, but you can, as a default, if there are no instructions, round to 2 decimal points. A statistics class might say 4, but for our purposes, 2 is enough. So there's our standard deviation. So this tells us there's a much wider spread amongst these points of data than there was in the previous set of data. You can kind of compare them that way. All right, let's see the other example. I don't think anything else there. Yep, that's good. Okay, so we have our cost of living data for all these cities in Africa that we saw last time. Again, we're looking for range and standard deviation. So let's start with range. This will be our highest data point, which is 129, minus the lowest data point, which is 33. When we subtract there, we get 96. So this tells us there's a spread of 96 numbers from the lowest to the highest. Again, you use your judgment on if that's a big number or not. All we're really concerned with is actually finding that number. Let's change here. Okay, then for standard deviation, we have all of the data points. We're going to do data minus mean, and then square it. But before we can do data minus mean, we actually need to have the mean. Again, I'm going to spare you a little bit of the calculation. Remember, add up all of the data points for our mean. I don't have that number in front of me, but I have that your mean computation should have gotten you 46.25, which you should have rounded to 46. 46 is the number to use. If you use 46.25, while your answer is a bit more accurate, definitely more accurate, 46 is much easier to deal with in computation. So just watch. I would say most of the problems you'll see in an online homework system are going to be whole numbers as a mean anyways, because they don't expect you to go through the process of dealing with those decimals. But in the real world, the decimal could happen. But anyways, let's go with 46 for our purposes. 46. Okay, so data point minus mean. 129 minus 46 gives us 83. 62 minus 46, 16. 45 minus 46, negative 1. 44, negative 2. 43, negative 3. 41, negative 5. We see that one twice. And just like with the mean, all data points get used. 40 minus 46, negative 6. 39 minus 46, negative 7. 38, we have twice, negative 8. 37, negative 9. 36, negative 10. 34, negative 12. And 33. Subtract the mean, negative 13. Then we take each of those numbers and square them. Some numbers large, some not so large. 6, 8, 8, 9. 256. 1. 4, 9, 25. I'm just squaring all the numbers from the previous column. 81, 100, 144, and 169. This is all just to get that numerator. Now that we have all that information, we take all of those numbers and add it up. The sum of those numbers, 7,952. And remember, that is what we've got in the numerator. The sum of, here we added up, x minus x bar, quantity squared. Each of those numbers added together. So 7,952 divided by, how many data points do we have? 16. 16 minus 1. Divide by 15. Doesn't look like we get a clean number. So when we type this radical into the calculator, we get 23.02. That's where it'll round to. So again, this number gives you an idea of what the spread of the data is. There are many more measures of variation that we have, measures of dispersion. But for our class, we're just getting introduced to these two because truthfully, in the real world, range is an easy one that's helpful, but standard deviation is probably a number you're going to come across at some point. And so it's helpful to have a good understanding of not only how to compute it, but what exactly it means. Okay, so that covers the material for this section. I want to make one more comment on the fact that in this section, it's kind of difficult to see how the statistics could really be skewed, as we've discussed throughout this section. And the truth is, even just looking at this data right here, there would often be the case made for tossing out the data point of 129, since it's not very close to the rest of them. And so while that taken out would certainly affect mean, median, mode, it would definitely have a big impact in what the variation in the data was. So it's always someone's choice if they want to keep all of this data, if they want to toss that one out and say, here, all of these are much closer together, then maybe they can tell you there's not actually that much variation in these cities in Africa, when truthfully it was their choice to exclude some data points. So any type of statistical information you're looking at, while the numbers may have been crunched correctly, the choices made along the way might have some sort of impact on it. And so that's something I hope you'll keep in mind with every single piece of data that you see. All right, so we saw measures of central tendency, and then we saw measures of dispersion, which was this video on where the data could get pulled in either direction and what that would look like. So I'll see you soon for another video.